morning. We're going to talk about graphing rational and irrational numbers on a number line. So the first thing we're going to do after we look at our numbers is to find the decimal approximations for all of the numbers. So we're going to start with the first number and work our way across until we have all 5 of these numbers approximated in decimal form. So the first thing we're going to look at is 7/2. And again, we want to find the decimal approximation. So we're going to do 7 divided by 2. And I'm going to put a decimal point and a 0 because I know I'm going to have to go to the tens place. So 2 goes into 7 3 times. 2 times 3 is 6. So we're going to subtract that 6. 7 minus 6 is 1. And we're going to bring down the 0. I'll bring my decimal point up here. 2 goes into 10 5 times. 2 times 5 is 10, and we're left with 0. So our decimal approximation, or our decimal form for 7/2 is 3.5. So we're going to try our next number. So let me erase this. And we're going to do the square root of 5. So as we did on the last video that I gave to you guys, we're going to estimate, we're going to look at 5, the square root of 5, and figure out what number is going to be closest to this when we square it. So if I'm looking for the square root of 5, the number that's close to it would be 2 squared, which is 4. And I know that the square root of 4 is 2. And then the next biggest square after 4 is going to be 9, because 3 times 3 is 9. So we know our number is going to come between 2 and 3. And we have to determine, in order to not have to do all of the multiplication, 2.1, 2.2, 2.3, 2.4, we're going to look and say, is 5 closer to 4 or is 5 closer to 9? Well, we know there's 1 unit difference between 4 and 5 and 4 units difference between 5 and 9. So I know I'm closer to the 4, which means my answer is going to be closer to 2. So let's try 2.1 times 2.1. 1 times 1 is 1, 1 times 2 is 2, 2 times 1 is 2, and 2 times 2 is 4. That gives us 4.41. And it's not very close to 5. I mean, it's close to 5, but it's not as close as I'd like to have it. So I'm going to try 2.2 next. Get a little bit bigger. 2 times 2 is 4, 2 times 2 is 4, 2 times 2 is 4, and 2 times 2 is 4. We get 4, 8, 4. Remember to move our decimal place over 2 spots, so we're at 4.84. Now, 5.00 minus 4.84 gives me 0.12. So I'm 12/100ths away from a 5. So that 12/100ths is pretty close, but I want to make sure that I am not missing another number. So I'm going to go bigger than 2.2, see if the next number up is going to be closer. So I'm going to do 2.3 times 2.3. 3 times 3 is 9. 3 times 2 is 6. 2 times 3 is 6. 2 times 2 is 4. Put our 0 placeholder there. And we get 9, 2, carry a 1 is 5. 5.29. So let's see what the difference between 5.29 and 5.0 is. 9, 2, and our decimal point. So we are 0.29 away from 5 when we do 2.3 times 2.3. And when we did 2.2 times 2.2, we got 4.84, which was 12/10ths away. So our answer for the square root of 5, since we're closer to 12/100ths is closer to 5 is the distance between 5 and 4.84. So we're going to use that 2.2 that gave us 4.84. So I'm going to write a 2.2 up here. And then we're going to solve for the next number. So negative 3.6 is already in its 10th place. It's already in decimal form. So we're actually going to leave negative 3.6 just as it is. Repeating. Now we're going to do negative square root of 7 over 2. This one's going to take a little bit more work than the others because not only are we going to have to find the root of 7, we're also going to have to divide that by 2. So let's start with, we're not going to worry about the negative, just the square root of 7. And we know that the perfect square, or the square that's closest to 7 would be 4, because 2 times 2 is 4, and 4 is lower than 7. And if we do the next biggest root, this would be 3, and 3 times 3 is 9. So we're going to look for which of these numbers, 4 and 9, are closest to 7. Well, 4 to 7 is 3 units, and 7 to 9 is 2 units. So we're a little bit closer to 9 than 4, but we're kind of in the middle. So I'm going to try a number in the middle. So I'm going to do, let's say, 2.4 times 2.4. And I'm just guesstimating because I know it's somewhere in the middle, but it's a little closer to 9 than 4. So I'm just going to try 2.4 times 2.4. 4 times 4 is 16. Carry 1. 4 times 2 is 8. Plus 1 is 9. 2 times 4 is 8. And 2 times 2 is 4. So we bring down our 6. 9 plus 8 is 17. Carry a 1 is 5.76. We're pretty far away from 7, so let's skip 2 and go up to 2.6. Six times 6 is 36, so we put a 6 and carry a 3. 6 times 2 is 12, plus 3 is 15. 2 times 6 is 12, carry a 1. 6 times 2 is 12. 2 times 2 is 4, plus 1 is 5. So we bring down our 6, our 7, and our 6, which leaves us with 6.76. That is pretty close to the 7 that we're looking for, but I always want to go one bigger to make sure I have a number just below 7 and just above 7. So next we're going to do 2.7 times 2.7, and let's see how that works. So 7 times 7 is 49. So we put a 9 and then we carry a 4. 7 times 2 is 14, and 14 plus 4 is 18. 2 times 7 is 14, so we'll put a 4, carry a 1. 2 times 2 is 5, plus 1 is 6. So we bring down our 9. 8 plus 4 is 12, carry a 1. 1 plus 1 is 2, plus 6 is 8. So I did something wrong on that. Oh, this should be a 54. I apologize. So this would be a 7. So we're going to find the difference between 6.6 and 6.76 and 7, and the difference between 7.29 and 7. So 7.00 minus 6.76 is 0.24, and 7.29 minus 7.00 is 0.29. So 0.24 is closer is smaller than 0.29, so we're going to take the root that gave us an answer of 6.76. So we use 2.6, but we have to do the square root of 7 divided by 2. So I'm going to squeeze this in on the bottom. So we're going to do our square root of 7, which was 2.6, and we're going to divide by 2. So 2 goes into 2 one time, subtract our 2, which gives us 0. 2 goes into 6 3 times, which gives us 6 minus 6 is 0. So we have to remember our decimal point. So our final approximation for the square root of 7 over 2 is going to be 1.3. Let's do our final number, which is much easier than the last one we did, because we're just going to do the root of 14 over 3. I'm sorry, not the root, just 14 divided by 3. So we're just going to do some division. We've got 14 divided by 3. I'm going to put a decimal point in the 0 because I know we're looking for our tenths. 3 goes into 14 4 times, which 3 times 4 is 12. I'm going to subtract that. 14 minus 12 is 2. We're going to bring down this 0. 3 goes into 20 6 times. 3 times 6 is 18, which leaves us a 2. I'm going to bring my decimal point up. I should have done that to start with. Now I've got 4.6, but I need to see if this 0.6 is going to round, so we're going to have to go to the hundredths place. So we're going to put another 0 here and bring that down. And 3 goes into 20 6 times. And 6 times 3 is 18, which leaves us a 2. So that gives us 4.66. So rounding that, or that's actually going to be repeating, because if we did this again, we'd get 20, and 3 goes into 20 6 times. So I'm going to stop at the tenths place and say that it's 4.6 repeating. So we have our approximations, and now we can go ahead and start with our number line. So let's go ahead and graph these numbers. We're going to start with 3.5. That's positive, so we're going to go to the right of the 0. We're going to count out 1, 2, 3, and then we're going to be midway between 3 and 4. So this is going to be, we're not going to write 3.5. We're going to write the original number we were given. So that's going to be 7 over 2. So we're done with that one. Now we've got square root of 5, which simplified to 2.2. So we're going to go to 1, 2, and then in the middle, well, closer to the front, but between 2 and 3, we're going to put our 2.2, which is actually the square root of 5. So we're done with that one. Now we've got negative 3.6 repeating. So we're going to count 1, 2, 3 on our negative side, and then go just a little bit past the half mark, which gives us negative 3.6 repeating. We're done with this one. Now, negative root 7 over 2 gave us negative 1.3. So I'm going to count to the negative 1 and then go a little bit past that to give us negative 1.3, but we write it as the square root of 7, negative square root of 7 over 2. Done with that one. The last one we have is 14 over 3. It approximated at 4.6 repeating. So we're going to count 1, 2, 3, 4, and then go a little bit past half, and we're going to write 14 over 3. Remember, as you're writing your, drawing out your number line, that you're going to use the original numbers you were given, not the approximations. I hope this helped.